All right, class, welcome back. This is 8.2 still, and we're still working on solving quadratic equations, but this time we're going to talk about how we can use the discriminant to determine the number and type of solutions that we might get. So this is the entire quadratic formula, but the discriminant is just the portion that is under the square root. So it's this b squared minus 4ac. So what we're going to do is we're going to give three different problems, and we're going to say, well, how can we tell what types of answers we're going to get? So there's one problem. Another problem, and another problem. Okay, so before we can plug into the discriminant, remember that it has to be in the format of ax squared. To identify a, b, and c. So this one is good. So we're going to say a is 2, b is 3, and c is -7. All right, so I'm only doing this part. Again, this is the full quadratic formula, but we're only talking about the discriminant right here. So I'm going to do b squared minus 4ac. Well, b is 3 squared minus 4 times a, which is 2 in this case, and c, which is -7. Well, 3 squared is 9. And then I'm going to add 8 times 7, which is 56. So the discriminant here is 65. This discriminant is positive. It's a positive number. And remember that the discriminant is what's under the radical. So really we're talking about is what under the radical, what's under the radical. Is it positive? Is it 0? Is it negative? What is it? So in this case, it's positive. Well, what this will mean is that you will get two real solutions. Real meaning they will not contain I. Okay, so there will be no I in your answer. Well, that makes sense because in order to have I in my answer, I would have to have a negative under the square root. But in this case, I would have a positive under the square root. So I'm just going to get stuff like 2 plus or minus the square root of 5, or 8 plus or minus 2 square roots of 7, or 3 and 1/2. There'll be positive solutions. So you'll just have to identify what type of solutions you would get by using the discriminant. Here, to use the discriminant, I'm going to have to put this in this form right here. So we will get that x squared minus 8x plus 16 is equal to 0. And now I can identify a is 1, b is -8, and c is 16. So I'm going to have b squared, which is -8. Again, we're using this right here, the discriminant. Minus 4 times a, which is 1, times c, which is 16. Okay, so 8 squared is 64, and 4 times 16 is also 64. So we get this 0 here. Well, that is a weird solution. I'm going to talk about this more in just a minute, but this isn't positive or negative. This is 0, right? So if we get a solution with 0, then we're going to have one real solution. Now, some of you might be thinking, wait a minute though, this was squared, so I should have two solutions. Regardless, won't all of these give me two solutions? Well, they should, and let's see if we can figure out why there's only one real solution here. We'll come back to this one right here, so let's talk about this for just a second. If I look at this again real quick here, and notice this is a perfect square trinomial. So it's going to be x minus 4, or I could use hippobutts to factor this, but again, I'm just going to say, well, these are factors 4 and 4, and they're both negative, equals 0. Well, you can see here that if I set each one of these factors equal to 0, or I say, what would I have to plug in for x to get 0, then x would be 4 here, and it would be 4 here. Well, this isn't two solutions. This is only one solution. And what this means is that I have a repeating solution. So you do get one real solution here, but it's a repeating solution. And this happens when you have a perfect square trinomial. Again, right here, perfect square trinomial. So there are actually two solutions, but it repeats. So we only count it as one, because when there's a solution that repeats, we don't write it twice. We only write it once. Hope that's helpful in understanding why you would get only one solution. And this next one, let's do this one. We haven't done one yet that doesn't have a middle term. So no middle term here. Actually, I think it was equal to -4. So we need to put it in this format. There we go. So again, this is equal to 0, but notice that there's no x term here. Well, that's fine. We can still identify a, b, and c. A is going to be 5, coefficient of the x squared term. B is 0. There is no x term, so it must be 0. C is going to be 4. So I'm going to plug in to the discriminant again. I'm going to say, well, 0 squared minus 4 times a times c. All right, well, 0 squared is 0, and I'm going to subtract 20 times 4, which is 80. So here I get a negative 80. So here my discriminant is negative. And what this means, because again, remember that we're talking about what's under the square root. We're only using the discriminant, and the discriminant is the part that's under the square root. Well, if what's under the square root is negative, then you're going to be able to factor out a -1, which is a complex number, or the complex number I. So when you have a negative number for the discriminant, then you will get two real solutions here. And those real solutions, two complex solutions, two complex, I read right here when I was talking, two complex solutions. What that means is they'll have an I. They'll contain I. So difference between complex and real. These real solutions can be whole numbers. Like I said, you could have like 8 and 1/4. Or you could have 2 plus or minus the square root of 5. This is real. Real radicals are included in the real numbers. And complex numbers will contain I. So that is how to use the discriminant to determine the number and type of solutions that you'll get.